Let's go to the beginning of the universe. The head of the space telescope, back, 20 years ago, a long time ago, he proposed something, and everybody says, "What a waste of time! What an idiot!" People call him names and stuff. And he was the smartest guy in the room, obviously. What he said is, let's take a look at a space somewhere in the sky where there's nothing, totally dark, not clouds, but just clear. And they did. They found a place in the Big Dipper. I said, okay, let's take a picture of this for like 2 weeks. Let's just soak in the light in the cameras. All right. Well, what are we taking picture of? Well, we're taking pictures the picture is called Hubble's Deep Field. And this Hubble Deep Field now is gone because it takes so long, weeks and weeks just to take one picture. We've done a few now. There's a Hubble Deep Field South. There's a Hubble Ultra Deep Field, and so on. So what we got here? This is the very first galaxies to be born, right? That's an awesome picture. We can see what the galaxies look like way back then. If I ever ask you a question, like when you look at a galaxy that is 10, 12 billion years old, what do you see in the telescope? Well, what do you see is a super young galaxy, right? You're looking at a young galaxy. Right now it's probably very old if you go there, but what we see has taken like 12 billion years to reach us. So we see it the way it used to be 12 billion years ago. That's what these guys look like then. They don't look like that now, so we see a very young galaxy. You guys follow that reasoning? Somebody give me a yay.
Because we can't see what it looks like now until it gives that light enough time to travel to us.
Right. So now what we're looking at is very, very young galaxies. This is the way universe looked at the beginning, right? After the galaxies formed. So we're talking about like maybe just 500 million years into the life of the galaxies. Originally, galaxies formed most likely from a seed. That seed being supermassive black holes. So supermassive black holes throw in a lot of dust and gas. What do you get? Well, see, the black hole is rotating. It's going to collect a lot of dust and gas. It's going to make it into a disk. And so you have a disk. You have a lot of stuff towards the center because it's a black hole. And so eventually they're going to become like the Milky Way. Right now, they're super young galaxies. So now, when we look, what kind of galaxies do we see? What kind of galaxies? Let me just go over. Spiral, 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 spiral. Well, they're all spirals. I don't have to keep going, right? They're all spiral galaxies. So at the beginning, they're all spiral galaxies. So maybe that gives us a clue as to how the universe evolves. What happened? How did the irregulars come to existence? How did the ellipticals come into existence, right? Well, let's see. Remember I said the big galaxies eat tiny galaxies? So let's see. Look at these guys. They're colliding. Every time they collide, they deform each other, basically, right? They deform the spiral arms. Spiral arms don't look like spiral arms anymore. What do they look like? The spiral arms are looking more like an irregular galaxy, like this one here. If I take just this section here, imagine I'll make a picture of just this. What do you think it is? Well, sure looks like an irregular galaxy. Okay. So irregular galaxy, another irregular galaxy is probably here, another irregular here. So when these guys collide, spiral arms get thrown off and they can form their own mini galaxies because gravitationally they're going to come back together again, right? And when they do, it can be a irregular galaxy. Now, what about the ellipticals? Well, there's a beginning here. Two galaxies are colliding. We're not sure exactly what's going to happen once the collision is finished. But this one here is a famous galaxy. This is called the mice. So if you guys can see the mice, this is the eye of the mice. You see the eyeball? You see the nose of the mice, the head of the mice, body of the mice, and the tail of the mice. Do you see the mice now? It's got a mohawk, a blue mohawk, and whatever you call this, like a little strand of hair in front of his face. So now, this mice shows us how elliptical galaxies can form. These guys collide, and they pull each other's spiral arms off. What is there left? They're bulges. Now, what are the bulges? Population 2, old red giants and supergiants. Okay. What are the elliptical galaxies made of? Old stars. No gas. What happened to the gas? They're pulling each other's gas out too. Look at that. They're pulling the gas out. So if you take the gases out, take the spiral arms out, and you only have population 2 stars, old stars, what do you got? Elliptical galaxies. So then elliptical galaxies evolved from the spiral galaxies bulges. So the bulge becomes the new elliptical galaxy.